Hello my dear students, how are you? Namaste to all. Today I am giving you very interesting lecture about the what is sulfur dioxide gas. That is the what you see compounds of oxides of what we can say sulfur, and that is very important for examination as well as knowledge. So what you see sulfur. Its molecular formula, MF means molecular formula, is SO2. Its molecular weight is 32 plus 32. How much? 64. Its vapor density 64 by 2. How to get 32? Yes. So that is our general knowledge of sulfur dioxide. It's very important for examination. Always ask in examination. So at first, lab preparation of sulfur dioxide gas. So when copper turnings mean cutting of copper turnings are heated with concentrated sulfuric acid, we get sulfur dioxide gas, which is collected in gas jar by upward displacement air. Why? Because it is heavier than air. So reaction is like this. Reaction involved. Reaction is like this. So copper turnings. So when heated with conc sulfuric acid, so what we have? Copper sulfate, that is copper sulfate plus H2O plus sulfur dioxide gas. What we have? Copper. So what we see? H2SO4. So how many oxygen? 4. 1 sulfur. 2 sulfur over there. So we have to multiply over 2 there. 2H, 2S. So what you see? Oxygen is 4. 2H means 2H2O. Yes. So we have to balance simple by heat and trial method. So by this method we can prepare sulfur dioxide in the lab. So that is very important for us. So when you talk about this, what you see physical properties, it is colorless, odorless gas, what you see, and it's irritating smell, and it causes suffocation. So now we have to study important. So that is about the lab preparation. Now the important one is important chemical properties of sulfur dioxide gas. Yes. So first one is acidic character. Acidic character. Yes. So it is sulfur dioxide gas is anhydride, at deficiency of anhydride of sulfurous acid, which is diprotic, or we can say dibasic in nature. It means it has two replaceable hydrogen. Yes. So what do you see? Anhydride. Anhydride means deficiency of water, you can say. So what do you see when SO2 is treated with water? So what we get? Sulfurous acid, that is known as sulfurous acid. Yes. Now this sulfurous acid and ionize, what we have? H plus SO3. Yes. So how many replaceable? 2 hydrogen. So it makes 2 type of salt over here. So what we see when this sodium hydroxide base, first molecule, when treated with sulfurous acid, so 1 H is substituted. So what we have? NaH SO3 plus what you see? Water. That is known as sodium hydrogen sulfide. SO3 means sulfide. Yes. So what's now it has 1 H over here. So it reacts with another molecule of sodium hydroxide. So what we have? NaH. So that H is replaced by this another molecule of sodium hydroxide. And what we have? Na2 SO3 plus H2O. That is known as sodium sulfide. Yes. So what do you see? It has 2 replaceable hydrogens. So it forms 2 salt over here. One is sodium hydrogen sulfide, another one is sodium sulfide. In this case, what do you see? What do you observe? Both H of the sulfurous acid is substituted by sodium metal. Yes. So it forms 2 type of salt. So it is, what do you see? Dibasic. Diprotic means 2 replaceable hydrogen. It has what do you see? 2 replaceable hydrogen. So it forms 2 type of salt over here. It's like this. Yes. First one is a acidic character. Next one is catalytic oxidation. So we have already studied in sulfuric acid. So what do you see when sulfur dioxide is reacted with oxygen? What do you see? Either platinum or vanadium pentoxide catalyst at what is it? 450 degrees centigrade, 2 to 3 atmospheric pressure. Yes. So what we get? So we have already studied what is sulfuric acid, and that is known as catalytic oxidation. Why? Because oxidation takes place in presence of catalyst, platinum or vanadium pentoxide. That is vanadium pentoxide. So what we have? Sulfur trioxide. And what we see when balance this one? 2SO2, 2SO3, so mean 4 to 6, 4 to 6. Yes, and it liberate 45 kilocalorie per mole. I have already discussed about the what we say reversibility and exothermic reaction of Lee-Chater principle of already I think. So I've already talked in sulfuric acid. So that is second one, catalytic oxidation. Fourth one is third one, that is very important, as reducing agent, or we can say simply reductant. Yes, very important property generally asked in examination. So first one is with acidified solution of potassium permanganate. Yes, formula is KMnO4. Yes, when acetic gas is passed through acidified solution of KMnO4 potassium permanganate, we get colorless manganese sulfate by reduction process. Yes, like, so what we have, so see KMnO4 plus SO2 plus H2O, what we get? K2SO4 MnSO4, that is manganese sulfate plus what we see? H2SO4. Yes, what we have? Manganese has +7 and its color is what you see, pink, but it becomes what you see, colorless. Why? Due to formation in this case +7 oxidation number, in this case +2. Now question is how it comes. So I've already talked you about the partial equations. So at first KMnO4 react with dilute sulfuric acid, potassium sulfate, manganese sulfate, H2O plus, that is nascent oxygen. Yes, nascent oxygen. Now this nascent oxygen react with sulfur dioxide plus H2 plus O, that large bracket, what to get? Sulfuric acid. Yes, so when you balance this one, so we get, after balancing, so we get 2 KMnO4 plus 3H2SO4, what you get? 2MnSO4 plus 3H2O plus how many oxygen? 5 oxygen. Next what we have? H2SO4, so already balanced. So in this case we have to cancel this oxygen. How many? 5. 1 oxygen. So we have to multiply by 5. So what we get? And after multiplying, what we have to do? What is it? Cancel 1. So what we get? 2 KMnO4 plus how many sulfuric acid? Sulfuric we have to substitute in this case. So what we get? 5 SO2 sulfur dioxide plus 2 water in left hand side, K2SO4 plus 2 MnSO4 plus what we have? 2 sulfuric acid. Yes. So what is it? 2 Km, that is the main reaction. So it's 2 KMnO4, 5 SO2, 2 H2O, right hand side 2 MnSO4, 2 H2SO4. Yes, that is balance. Yes, so that is the main reaction, and that is the what to see how we get this reaction. Yes, A with acidified solution of what is potassium permanganate. So in this case, what we get? The color of pink is +7, and what we see after reduction, what we get? Manganese sulfate. So in this case, oxidation number is +7, but in this case +2. So what the function of this sulfur dioxide? Reduces from +7 to +2. Yes, I think no. B with acidified solution of potassium dichromate. Potassium dichromate. Yes. So when language like this, generally asking what happens. So when sulfur dioxide gas is passed through acidified solution of potassium K2Cr2, say potassium dichromate, we get green colored chromium sulfate by reduction process like. So what you see? That is the potassium dichromate. Potassium dichromate, plus dilute sulfuric acid plus SO2 in left hand side, potassium sulfate, chromium sulfate plus what you see? Water. So that is chromium sulfate, and its color is green color. Its color is what you see? Orange yellow. So oxidation number chromium is +6. In this case +2. So what do you see? The function of this sulfur dioxide reduces +6 to +3. So what type of reaction it is? Reducing. Now question is how it comes. Same. So what to see? So at first, potassium dichromate plus dilute sulfuric acid. So what we have? Potassium sulfate plus chromium sulfate plus what is H2O plus nascent oxygen. Yes. So main reaction, dilute sulfuric acid, H2O, what we get? H2, better to say. That is the main reaction. Now, how will you get? So this one. So at first what you see? K2Cr2 plus dilute. First step, so what you get? K2 potassium sulfate, chromium sulfate plus H2O plus nascent oxygen. Yes. Now this nascent oxygen will react with sulfur dioxide. So what we have? Sulfuric acid. Yes. So after balancing, what to get? K2 4H2SO4 and right hand side 4H2O and what to see? 3O, 3 nascent oxygen over here. Yes, SO2 already balanced. So in this case 1 oxygen is 3 oxygen, in this 1 oxygen we have to multiply by 3. So at first we have to cancel this nascent one. So after adding and subtracting, what we have? K2Cr2 plus 4 dilute multiply by 3. In right hand side K2SO4 chromium sulfate plus 4H2O. Yes, 4H2 and in this case 3H2. So how much? 2H2O. Yes, 3, 4, 3H2O, 4H2O. What one remaining one is 4 minus 3. How much? 1. So that is 1H2. Yes, that is balanced chemical equation. Yes. Now see, with acidified solution of ferric sulfates. So what we have? So when this ferric sulfate Fe2SO4 is treated with what is the dilute sulfate SO2, what is here? SO2 plus what we see 2H2O. So what we have? 2 ferrous sulfate plus 2 sulfuric acid, that is ferrous sulfate. Yes, in this that is ferric. What do you see in this case? Oxidation number is +3. In this case, oxidation number is 2. So what the function of sulfur dioxide over here? So what is SO2? It's already balanced. Yes, balance. C. So sulfur dioxide reduces ferric sulfate to ferrous sulfate. In this case, +3 oxidation number. In this case, +2. D with chlorine water. Chlorine water means when chlorine dissolved in water is known as chlorine water. So when SO2 is reacted with chlorine water, we get hydrogen chloride by reduction process like SO2 Cl2 H2O. What we have? HCl plus sulfuric acid. So what the rule? Sulfurity is 0. In this case -1. So what you see? SO2 reduces chlorine to HCl. Yes. In this case, sulfur dioxide reduces chlorine to hydrogen chloride. So it is reducing gas. So always, so we see it's what's the oxidation number. If you know the oxidation number, we have never problem to solve such type of problem. After balancing, what we have? SO2, 2H2O, 2HCl, and what we see? Sulfuric acid. Yes, that is hydrogen chloride. Yes, I think you know. So when you ask, say write down the reducing properties of sulfur dioxide, we have to write the 4. Sometimes ask you what happens when what sulfur dioxide is reacted with acidified solution of KMR4. What happens when what you see SO2 is reacted with acidified? We have to at first write the language, then we have to write the what's a balanced chemical equation. Yes, so that is as a reducing agent. Fourth one is generally asked as mild oxidant. Mild, not so weak, not so strong, in between we can say. So when SO2 is reacted with hydrogen sulfide, we get sulfur by oxidation process. Like, look at the reaction over here. So what you see, SO2 plus H2S. What we have? H2O plus sulfur. So what the role of sulfide is? -2. In this case, sulfur has 0. So what it does? This sulfur dioxide oxidizes hydrogen sulfide to sulfur. So it is oxidant in this case. It is oxidant. Why? Because oxidizes hydrogen sulfide to, that is hydrogen sulfide. Yes. So balancing, after balancing, what we have? So what is 2H2S, and what we see? SO2, 2H2O. How many sulfur? 3S. And that's arrow indicating downward means what we see? Deposition of what is sulfur over here. Yes. So the 4 ones, all are the important. Only we are talking about the important reaction which are generally asked in the examination. Yes, 4, 5. So what is bleaching? Bleaching properties of sulfur dioxide. At first we have to know What is bleaching? Bleaching properties. So those chemical substances which those chemical substances which decolorized coloring material in moist condition, always moist condition is known as its bleaching properties. Yes. So we take very simple example and very interesting. So when you see in what is lab, so what you see when SO2 gas is passed through moist pink colored rose flower, it becomes colorless due to reduction. But when it is exposed in air or treated with dilute sulfuric acid, we get pink color due to oxidation. Yes, very interesting experiment when they perform in what is lab. So pink color at first changes to the colorless, and when it is kept in exposed in air for some time, you are treated with dilute sulfuric acid, pink color due to oxidation. So what we have? At first, sulfur dioxide react with water. So what you get? Sulfuric acid, nascent hydrogen in this case. Nascent hydrogen, yes. Now this nascent hydrogen, pink, reduces pink color of rose flower. So process is reduction, and what you get? Colorless flower. Colorless flower. But when exposed in air or treated with dilute sulfuric acid, process is in this case is oxidation, and after oxidation what do you get? Oxidation, what do you get? Pink color reappeared. Yes. So what you see is when you talk about the main points over here, bleaching. And bleaching means to convert one color to another color is known as bleaching. Yes. So here bleaching properties is due to reduction. We have to keep in mind first point. Second point, here bleaching properties is temporary. So what do you see? In first case, pink color discharges, and when you treat it with air or what you see, dilute sulfuric acid, so what do you get? Pink color reappeared. So what do you see? First one is reduction, and second one is temporary. Third one is its bleaching. Bleaching properties is seen only in delicate means soft, delicate material like vegetable, flower, it is, but not in textile industry. It's very weak bleaching properties over here. So in this case, what you see, so I have already take. So this at first sulfur dioxide reacts with water, and what do we get? Sulfuric acid and nascent hydrogen, and that nascent hydrogen reduces pink color of rose flower into the colorless. But when it is treated with air or dilute sulfuric acid further, so after oxidation, what we get? Pink color reappeared. Yes. So what we see over here? Here bleaching property is due to reduction. First point. Second point is what is bleaching property is temporary. Third one is bleaching properties is seen only in delicate material like vegetable, flower, not in textile industry. So always keep in mind. So what do you see when balance? 2 years, 2 years. Yes. So that is very, very important, and generally ask, compare the bleaching properties of SO2 and Cl2. So this is about the what SO2. Now when see the bleaching properties of chlorine, bleaching properties of chlorine, next bleaching properties of what is chlorine. Yes. So here bleaching property like this, Cl2 H2, what to get? HClO plus HCl, that is known as hypochlorous acid. Yes, that is unstable and break down into HCl plus nascent oxygen. Yes, that nascent oxygen when treated with any coloring material, it decolorized. Decolorized means change from one color to another. So it's decolorized. So in this case, we have to note 3 points over here. First one, in what we say, SO2 is reduction. Here, bleaching properties is due to oxidation, but in sulfur dioxide, reduction. Here bleaching properties is permanent. We cannot change in original position. Third is bleaching properties is stronger than SO2 and bleach what is used in textile industry. Textile industry. Yes. So these are the what we say. So when we talk about the oxidation, in this case chlorine, bleaching properties of what is chlorine. So at first Cl2 react with yes, what we get HClO plus HCl, that is hypochlorous acid, that is unstable, that again decompose HCl plus nascent oxygen. Now this nascent oxygen what we see react with chlorine material, what we have dechloride material. Yes. So what we have to note over here, bleaching properties is due to oxidation. Here bleaching properties is permanent, but in SO2 temporary. Third is bleaching properties is stronger than SO2 and used in textile industry, cotton industry, wool industry. Well, it's very, very important. So question is asked. So compare the bleaching properties of SO2 and Cl2. It's very important, generally asked in examination. Yes. So I think we are clear. So I have already given all the points in the case of SO2, in the case of chlorine. Yes. Yes. So I think you can write. Next, last one is, it is acid reaction with NaOH, calcium hydroxide and sodium carbonate solution separately. So NaOH is base, you know. It reacts with sulfur dioxide, that is acid. So what you get, Na2SO3 plus water, that is sodium sulphite. Yes, likewise calcium hydroxide, that is also the base, when react with sulfur dioxide acid. So what we have, calcium sulphide plus H2O. Likewise, when talk sodium carbonate and SO2 solutions, what we have at first, sodium sulphide plus CO2, that is sodium sulphide if less. Yes, if it is high, so what we have, CO3 SO2 H2, high one is, in this case less, but in this high. So what we have, sodium bisulfate, sodium bi. So what you get, sodium bisulfite. What you see, carbon dioxide, H2O. Yes. So what you see, balance is like this, NaOH, 2 NaOH, Na2 sulphite, calcium already balanced, first sodium carbonate is already balanced, and what you see in second case, sodium carbonate SO2 plus what you see, 2SO2, 2H2O. So what we have, sodium bisulfite, 2NaHSO3. So what you see, plus CO2, not carbon. Yes, 2 is already in left side. Yes. So these are the main important properties of sulfur dioxide. Yes. And when we talk about the uses, so what do we see? Sulfur dioxide is used for the manufacture of sulfuric acid. You know, it is used as a strong reducing agent. It is used as what do you say, mild bleaching reagent. Next one, it is used to make different type of sodium sulfide, calcium sulfide compound, and last we can say it is used as lab reagent. Yes. So thank you for watching this interesting video, and I think you have already subscribed it and also convey to your friends for learning. And what is it? Have a nice day. Be happy. Be healthy. Be bona fide in chemistry like silicon, sir. Okay.